The mass is suspended by a helical spin with the pointer attached at its low end is shown in the figure. A student is asked to verify the relationship between the mass simple m with its periodic time t of vertical oscillations and determine the spin constant k by using the graphical method. Part A 1. Write down an expression for periodic time t of vertical oscillations of mass m suspended by a massless spin of spin constant k. We have to use the equation. We can write directly period is 2 pi root m over k. We have studied in theory note. Then part 2, rearrange the expression. It means A part 1 above in order to verify the relationship between mass m and periodic time t by plotting a suitable straight line graph. Now we have to decide the dependent variable and independent variable. We are changing mass held by the spin. Then simple m is the independent variable. We have to get it as the physical quantity in x-axis, and we have to measure time. It is dependent variable. We have to get it as the y-axis. But simple m is within a square root. We can't draw a graph with the square root. Therefore, we have to get the square of this equation. Then I will square our terms. T squared equals 2 squared 4, 5 squared, simple m over k. Now we can rearrange it. T squared equals 4 5 squared over k times m. It is in form y equals mx. Then we have to get t squared to the y-axis and m to the x-axis. Then part B 1. If the student is provided with a set of 50 gram weights, what is the other essential measuring instruments that he needs to this experiment? We have to measure the mass with time, mass and time. Then he needs a stopwatch. B part 1, stopwatch. Part 2, it is admissible by using locating pointer in these experiments. Draw an arrowhead at the appropriate position of the pointer in the above figure. I will draw the figure. There is a spin and this is the simple m weight, m mass. And we have to draw the pointer. Now in the given diagram, there is a stand like this. We have to draw pointer at this place, end of the spin, and we have to mark another pointer from the stand. Then part 3, what is the purpose of using this locating pointer? We can accurately determine starting and end point of oscillation. We have to start to measure the time at this point, and when oscillating this one, we have to count one oscillation is the point again reached to this point after complete oscillation like this. From this point it should move downward, then upward and again downward. We can write answer for part 3 to determine starting and end point. Starting and end point correctly. Then part C. Why does the accuracy in determination of spin constant depend mainly on the accuracy in determination of periodic time of oscillation of mass? We can see the equation. In equation, there is a square term for T. Then power of T is greater than power of M. We are measuring M and T. Power of T is greater than power of M. Therefore, we have to get T measurement accurately. If there is an error with T, its error will affect more than error of M because of there is a large power. Then we can write in T term part C1. In T term there is a second power. Then part 2, what is the characteristic property of the instrument method in B1 above which affect the fractional error of time measurement? Please count. Fractional error of percentage error is depending on two factors. First one is least count of the instrument. Second one is measurement we have to get. Then related to measuring instrument, the factor is least count. Then part 3, let the approximate time per oscillation be simple T. Write down an expression for the minimum number of oscillations N that should be taken in terms of X and T in order to obtain percentage error of 1% periodic time determined. Percentage error should be 1%. Then we have to write equation for percentage error. Percentage error equals to least count divided by reading multiplied by 100%. Percentage error should be 1. Least count is, they have given approximate time per oscillation be T. Then we are taking minimum number of oscillations N. In part 2, they have given this least count is X. Therefore, we can substitute least count as X. Reading T time for one oscillation, and we have to get simple N number of oscillations. Then Tn into 100%. Now we can subject N. We have to give an expression for N. We can subject N term 100x divided by T. This is the expression we have to write as the answer for part 3. In part D, they have asked the student obtain the following graph in order to calculate spin constant of K of the helical spin. Part 1, calculate the spin constant K of the helical spin in SI unit using the shown graph. Take 5 squared equals 10. Now we have to use the equation. According to this equation, we can get gradient of the graph. Gradient of the graph should be equals to this part of the equation. when finding gradient, we have to get two points of the graph. When getting 2 points, we have to consider 3 factors. First one is, considered points should be between marked range in the graph. Second one is, considered point should be a maximum gap. There is a maximum. There should be a maximum gap between considered 2 points. Third one is, we have to get 2 points such that we can clearly read x and y values. Then I will show the graph and points we can get. Now they have marked in the marking scheme. There are 2 points like this. When considering the minimum point from this end, they have marked x value and y value. For this point, x value 80, y value 30, and for this point, x value 280, y value 80. But when considering y value, we have to consider that y-axis is marked as t squared multiplied by 10 to the power 2. Then we have to write y value with multiplied by 10 to the power minus 2. See, 2 points they have marked. There is a maximum gap, and the points are lie between marked range, and we can determine x and y values correctly by using the graph. Then I will find the gradient by using considered points, and we can get gradient is equals to 4 phi squared over k. D part 1. Gradient equals 4 phi squared over k. Gradient is difference of y divided by difference of x. 4 phi squared over k. Now I will find the gradient by using points shown in the graph. We can subtract y values. 80 minus 30. But we have to put 10 to the power minus 2. 80 minus 30 into 10 to the power minus 2. In y-axis there is a power, 10 to the power value. 10 to the power minus 2. Divide by x value, difference of x values, 280 minus 80. 280 minus 80 equals 4. They have given that phi squared value is 10 divided by k. Now we have to simplify it. 80 minus 30, 50 into 10 to the power minus 2 divided by 280 minus 80, 200 equals to 4 into 10, 40 divided by k. Then I will subject k. We can cancel out 5 divided by 5, 1. 20 divided by 5, 4. Then k equals 40 multiplied by 4 divided by 10 to the power minus 2. K equals 40 into 4, 160 multiplied by 10 to the power 2. But we have to get the SI unit. In y-axis, they have given t squared multiplied by 10 to the power t squared multiplied by 10 to the power minus 2 seconds, square seconds. It is in SI unit. but x-axis they have marked in grams. Therefore, when considering difference of x, we have to convert this value to kilograms. Then we can multiply by 10 to the power minus 3 to convert kilograms. 10 to the power minus 3. Then we can cancel out 10 to the power minus 1. Now I will subject k. K equals 40 into 4. When bring 10 to the power minus 1 to this side, we have to multiply by 10 to the power minus 1. We can cancel out 10 to the power minus 1 and 0. Then 16 is the answer. Unit Newton per meter. It is the SI unit of spring constant. 16 Newton per meter. In part 2, give the reason for obtain a non-zero intercept, mentioning that there are error in data points is not acceptable answer. According to the equation we have found, we know that the graph should be in the type y equals mx. Y equals mx means intercept should be 0, gradient should be the plus constant value. Now, when considering given graph, there is a straight line, therefore it has a constant plus gradient. But there is an intercept. The reason for intercept is when deriving equation we are using that spring is a light spring. It means there is no weight for spring, but actually there is a weight for spring. Therefore, there is an intercept in the graph. We can write answer for part 2 because of there is a mass for the spring. There is a mass for the spring.